yesterday when we were doing them, we didn't have, or we did have common denominators for the most part, and then we had all the numbers that had just nice numbers on the bottom, not variables. And then we had a little bit of variables. Now we're going to deal with ones where we have to make common base monomials, and then ones where we get binomials in the denominator, and what do we do? Okay? And then all we have left is solving. That's it. That's all for this unit. And then we move on to polynomials next week. It's going to happen. It will be on Wednesday. Okay? So, rationals, because we want to finish the 2 units before Easter break. I want to get them done, and then you write your test before Easter break, and then when you come back after Easter break, yes, we'll still review, because we still need to be able to have a midterm after it. Still need to remember all of our stuff. But I would like you to have the unit test on these 2 done before Easter break. So what's going to happen, instead of having an in-class open book, what I'm doing is for rationals and polynomials, they're both, just kidding, they're both going to be assignments that have to be handed back in, so like hand-ins, instead of open book tests. So they're worth half of an open book test. Okay? So the assignments are still going to be in, because you can talk to each other and everything like that. So that's why they're worth a little bit less. Open books, you can have your books, but you can't talk to people. So the rational assignment will get handed out tomorrow. It'll be due next week. Okay? All right. So here we have 3 and p, and those are these monomials or binomials? Sorry? I was like, they sound so similar, I can't even hear what you said. Monomials, yes. So if they're monomials, they go in their own brackets. I want to make this bigger. These are so tiny. 300. Well, that's aggressive. Okay. So we have 3, and we have p, and we have 7, and we have p, and they both have in common what? P. So do I have to add another p to make their denominators both have p? No, they already have p. Check. Like, this one has a p, this one has a p. Perfect. Okay. Now, these ones, this one has a 3, this one has a 7. So we can make monomials be monomials, right? One is a 3, one is a 7. What can I make them both be? 21. So I have to multiply this one by 7, the right hand or the left hand side one, and the right hand side one by 3. Now we know we did it correctly if in the end when we put them together we actually have a common denominator, right? So when they're monomials, you put them all together. We run an equal sign down the left hand side. We have 35 over 3 times p times 7. What's that? 21p. Plus 2 times 3 is 6 over 21p. Oh, we did good. We done well. We rocked this. We have the same common denominator. It's me raising the roof. That's supposed to be funny. All of you are dying from heat exhaustion. First off, I'll open another window. Second off, period 4, you're done. Third off, that was hilarious. And I don't know why you can laugh about that. LOL, one might say. There's all right, what do I have to do? State. Thank you. So I have a 21 and a p. Does the 21 do diddly? Does the 21 do anything? No, the 21 does diddly squat is what I want. So I just have p can't equal 0. Poof, done. Okay, when I have a common denominator, I can write everything over that denominator. Good call. No one's answering, so I'm answering for myself. 21p. Then on the top, I have 35 plus 6. What can I do with that 35 plus 6? Yeah, 35 plus 6 is 41 over 21p. Can I reduce those at all? Nah. And I have to put behind it, p can't equal 0. Finito. B, my denominators are what? Monomials or binomials? Monomials. Can I make a monomial be a monomial? Yes. It's like a tongue twister. Monomial, be a non-monomial, be a monomial. It's really hard to say. So I have a 3 and a y and a 5. Do they have anything in common? The left-hand side has a y. Does the right-hand side have a y? No. So I know at the very least I'm going to have to multiply by y. Okay, cool. Now they have y's. I'm going to do this middle step. You don't have to do this, but I'm proving the point. Now I have 1 over 3y plus 6y over 5y. Are they the same? What can I make them both be? 15, right? Can you do it in a couple steps if you need to? Yeah, you can. So, this one we can multiply by 5. Let's look at the 5 what it is. This one we can multiply by 3. And we get 5 over 15y plus 18y over 15y. And we get 5 plus 18y all over 15y. Can I put the 5 and the 18 together? No, the 5 is like a 5 guitars and the 18 is like 18 yams. I really like the word yam. I also really like yam fries. Just a fun fact. You don't like yam fries? Yam fries with dill dip? Mm.
Sweet fries with that. Sweet potato fries are sweet. No,
They're not the same. But in my head, I hear them the same. Do you think that Sam fries? Oh my gosh. Yam fries and sweet.
Weird.
Well, okay, but it's because I put yam and sweet together. I'm sorry. I apologize. Do you think that yam fries and sweet potato fries taste different?
Yep.
They're not the same.
They're not the same.
It's not true. They are not the same. I just can't tell the difference.
Potatoes are like orange.
Yeah, so I'm gonna go out. I'm gonna buy myself some frozen sweet potato fries because I'm gonna get real classy, and some frozen yam fries, and I'm gonna air fry both of them the same amount of time. All right, they are different. Oh, okay. I don't even know how that started. Oh, yeah. Can't put them together. That's why that happened. All right. I will do a test and I will come back and report to you if I can tell the difference. I still don't think I can, but we're gonna try. Okay, look at C and D. Aren't they lovely? They say, try me. So you try them. So we have a 6 and an X, a 3 and an X. What do they both have? An X, right, Jonas? I did. I asked him. No, you're calling him. They have an X in common. What does the one need? 2. Now remember, there's going to be some of you who are going to forget that this lovely subtraction sign goes to the whole thing, right? So we're going to get 2x minus 5 over 6x minus 6x minus 4 over 6x. Remember, this minus sign goes to both. And if you're someone who didn't do that again, leave yourself a little side note, because you're going to continually not do it, and then you're going to get it wrong because it's going to be a common error. 2x minus 5 minus 6x plus 4 all over 6x. And then we're going to collect xylophones. So 2 xylophones minus 6 xylophones is negative 4 xylophones. And then minus 5 popsicles plus 4 popsicles is negative 1 popsicle over 6x. Can the x's cancel off? Why not? This is a binomial, this is a monomial. So you can't cross a monomial off with a binomial and a binomial off with a monomial. And x can't equal 0 is our NPV. Okay. We're going to look at D. Okay, enough. So we're going to look at D. We have 2a squared and we have 5a. What's... Okay, what's missing? What's missing? An A and a 2. And what's this one missing? A 5. So we get 5A plus 35 all over 10A squared minus 6A all over 10A squared. Make sure you have equal signs running down the left-hand side of all of your rationals. Equal signs down the left-hand side. And then you can write over one denominator. Now we get 5A plus 35 minus 6A. And then you can collect like terms. So we get 5 apples minus 6 apples is negative 1 apple plus 35 all over 10A squared. What's my NPV? A can't equal 0 because it's a monomial denominator. It's just whatever the variable is can't equal 0. Then we're going to flip over. Okay, what's this? The denominator on the left is a what? Monomial. The denominator on the right is a what? Can we make a monomial be a binomial and a binomial be a monomial? No. You can make monomials be monomials. You can try and make binomials be binomials. But if you get a monomial in one denominator and a binomial in the other, you just multiply by each other. Right, Caleb?
Yep.
You take that phone out again. I'm going to keep it for life. I'm just going to start calling people.
For life?
Yeah.
I don't think that's a lot.
It's going to happen. All right. Yeah. So this one is a 2 and an x. This is an x minus 4. Honestly, when you get a monomial denominator and a binomial one, they're the easiest. You just multiply them by each other. You don't have to really think about it. I like them. They're my favorite. So this one I'm going to multiply by x minus 4. And this one I'm going to multiply by 2x. So I'm going to get x squared. I have to FOIL. Minus 4x. If you don't remember how to FOIL, please come in and ask. Minus 9x. Negative 9 times negative 4 is positive 36. All over. Now, if you have a monomial and a binomial denominator, you just leave them separate. Don't distribute them. You're just making your life harder because you're going to have to take the GCF back out. Because the moment you distribute your denominators, you're making them less simple. So I'm going to rewrite this one as 2x times x minus 4. And just leave them separate. And plus 3x times 2x is 6x squared. So remember, when you multiply these, they become bigger, right? But when you add and subtract polynomials, you can only add and subtract like things, like xylophones and apples and popsicles. Like, you can add those. Those are fine. When you multiply, you can multiply anything together. It'll just get bigger. Okay? But adding and subtracting, you can only put together like things. So here we have 2x and x minus 4. Now we have like denominators, so we can write it as 2x times x minus 4. And then we get x squared minus 4x minus 9x plus 36 plus 6x squared. And then I collect like terms. An x squared, 1x squared plus 6x squareds are 7x squareds. And then I do minus 4 xylophones minus 9 more xylophones. I have negative 13 xylophones. And then plus 36, it's just by itself. 2x, x minus 4. X can't equal what? What can't x equal? 0 and 4. And we have this one next. Can I make a binomial be a binomial? Maybe. If the binomial is like a difference of squares. So if you have like x squared minus 4, you can break that down to x plus 4x or x plus 2, x minus 2. And if the other one is an x minus 2, you can try and make them the same. But here I have a 2y plus 5 and a y minus 3. Do they share anything in common? Do they really share anything in common? No, one's a 2y plus 5 because it's attached, it's one whole thing, and the other one's a y minus 3. They share nothing in common. So how do I make common denominators? Just multiply them by what? Each other. That's it. I'm going to rewrite this so I'm not making it so squishy. So I'm going to have 4 over 2y plus 5. I'm going to multiply it by y minus 3. Minus 1 over y minus 3. And I'm going to multiply it by 2y plus 5. I never distribute my denominators unless my denominators are both monomials. So when we put them together when they were both monomials. Other than that, you leave them in their own brackets. Or else you make your MPVs way harder. So we get 4y minus 12 over 2y plus 5, y minus 3. Minus 2y plus 5. When I distribute a 1 in, it doesn't change anything. Over y minus 3, 2y plus 5. Do we have the same denominators now? Yeah. So can we write them over one denominator? What do we have to watch with that subtraction sign in the middle? That it goes to both. Everything behind it, right? So we're going to get y minus 3, 2y plus 5 in the denominator. And then we're going to get 4y minus 12. And we distribute the minus sign through. Minus 2y minus 5. Then our denominator is y minus 3, 2y plus 5. And then we get 4y minus 2y is 2y. 4 yams minus 2 yams. We had the yam discussion. And then minus 12 minus 5 more, minus 17. Can I do anything else? Can I cross off like the 2 y's or something? No, it's a binomial, right? What do I still have to do? MPVs. So I have y minus 3 can't equal 0. Y can't equal 3. Then the other one, people will tell me y can't equal negative 5. Which is not true. They forget to divide by the 2. So you have to remember that you can take the 2y plus 5. Now the people who do this in their head sometimes flip this to be 2 over 5, which is not what it is. So I never flip it, or I never just do it in my head. I'm going to subtract the 5. And I get 2y equals negative 5, or can't equal. And then I divide by 2. Y can't equal negative 5 halves. And I follow behind with that. I'll come right back to this in a second. I just want to show these. So I'm going to get you to do G. Do these have anything in common? Anything in common? Nothing in common. Binomial is totally different than the other binomial, right? So we'll have to multiply them by each other. This one, what's this? Difference of squares. So I'm going to get a p plus 1 and a p minus 1. Then what do they have in common? P plus 1. So this one just needs a... Actually, when you get a difference of squares one, I think they're easier. So you're trying out those two. And I'll put this back for anyone who's copying. So try out those two. So we get 2x plus 1 over x minus 5. And we need to multiply this one by x plus 1. We don't distribute our denominators. And we get x minus 4 over x plus 1. And I have to multiply this one by x minus 5. We distribute our numerators. We do not distribute our denominators. So my denominator is going to be x minus 5, x plus 1. If you distribute them, you're going to have to factor them back out, because that's how we get our NPVs. Right, Jonas? So we distribute, and we get 2x squared plus 2x plus 1x plus 1 minus x minus 5x plus 1, x squared minus 5x minus 4x plus 20. So we get x minus 5x plus 1 in the denominator, because we have a common denominator now. And we have to remember to distribute that minus sign through to every single term, right? So we get 2x squared plus 2x plus 1x plus 1 minus x squared plus 5x plus 4x minus 20. And then we collect like terms. So we get 2 xylophone squareds minus 1 xylophone squared is 1 xylophone squared. And then we get 2 xylophones plus 1 xylophone is 3, plus 5 xylophones is 8, plus 4 more xylophones, 12. And then 1 xylophone minus 20 is minus 19 xylophones. And x can't equal negative 5 and negative 1. Yeah. Ah, getcha. Well, why did I do that? That's stupid. Sometimes I tell you. Good catch. That didn't make it that much smaller. X minus 5. So then this would be plus. And this would still be minus. Changed the wrong one. Ah. All right. Then we have this one. This one's actually easier than the last one. I know it seems harder because it has that difference of squares on the bottom, but because of the difference of squares, it already makes it so that one is already good. So I only have to change the other one, right? The difference of squares ones are actually easier. So here we have 4 over p plus 1, p minus 1, plus 2p minus 2. We distribute our tops, but we don't distribute the bottoms, the denominators. P plus 1, p minus 1. The moment you have a common denominator, you can write it over one denominator, right? So p plus 1, p minus 1. This thing that keeps drawing is driving me nuts. 4 plus 2p minus 2. So we could do 2 popsicles. Hey, this one works better as a p. And then 4 minus 2 is positive 2. Does anyone spot anything I can do further?
out 2.
You take out a 2. And then they'll match. And then I'll want to cancel. Before I cancel, I slap my hand and I say, MPPs. 2, P plus 1, over P plus 1, P minus 1. P can't equal plus or minus 1. They cancel off. And I don't just do this and box it. There's nothing more annoying than when you guys give me this as your answer and box it because you're too lazy to write out the last step. It makes me take off 0.5 because it makes my heart hurt. So, rewrite one more step. I promise. Your pencil and you can do it. P minus 1, like you'll make it, you'll survive. And then P can't equal plus or minus 1. You are one of those people who continuously writes the answers with little slashes in them and boxing it. That is not an answer. An answer is once all the slashes are out. That's not simplified, right? Make sure you take them out. Your homework is in Google Classroom. I posted it. Not a ton of questions. It is not in 30-1. It's on page 450, and it's just 1BC, 2CD, 3B, 4C, BC. So it's 7 of them. Right.